Okay, this is a video explaining my thought process behind the celebrity lookalike application. And as I always like to do before I start a project, I just try to put the idea in a rough map of what I expect to happen before I start trying to get over here and code. And as I code, I also redevelop this at the same time, so that's why it looks so good. If you can see these in the beginning, they don't look terrific. But just a quick overview. Of course, you got your imports. This is mainly done using Dlib and OpenCV. In particular, we want to use Dlib's face detector, um, landmark, and face recognizer. And then, of course, we're going to have some data sets here. We're going to have a folder full of a whole bunch of celebrities. Now, we've got a small one here. I don't want to have every celebrity I could think of, but quite a few. The mapping of their names to the folders, and then just a few images to test. And um, basically what happens is you load the face detector, load the landmark detector, and load the face recognizer. The face detector detects the face, landmark detector detects the landmarks of the face, and the face recognizer turns that into 128-bit, not 128-bit, 128 vector. Now over here, you can see where I've imported the modules I need. Um, face detector is one of these are one of the first things you want to include. And the reason I'm including these first is because if I include them in the function, it slows it down too much. So each function here, this one enrolls the data. Now the idea behind this is I enroll the celebrities first. Take that mini celebrity mini, and I enroll them into the face detector so that it recognizes those specifically. Then I create a um, a 128-bit array that is then processed in a higher dimension. Now, this is a 2-dimension, but trying to represent a cluster in a 2-dimensional plane, and essentially enroll those. Now, when I went to go find the lookalike, what I do is I run the same process again. I again enroll the new users, but then I see how those clusters of 128 um, length vectors, see how those clusters actually, what the distance is between other clusters. And what I've discovered, then you compare the distance using the Euclidean distance formula, pretty simple. And what you end up getting is you end up getting a picture that looks, and then I've had the app pick out the picture that just in the folder that corresponds to the closest um, cluster relationship. Now, if you come down here, you can see, keep calling it a cluster, but it's actually a point. You can see here some of the results we have. Those look pretty good, and we have one here that's not so good. It was the Rock, but he wasn't included in our original data set. So I suspect that if we had put more celebrities in there, he would have been easier to pick out. That's a general idea behind it all. You can find my code on GitHub and feel free to read through. I try to keep up with the documentation so it's easy to understand what I'm doing. And if there's any questions, feel free to email me. Thank you.